Welcome to Software Design and Modeling. After watching this video, you will be able to compare and contrast the terms structure design and behavioral models, describe Unified Modeling Language or UML and its advantages when designing software, and discuss the purpose of an interaction and a state transition diagram. Software design is a process during which structural components and behavioral attributes of the software are documented before it can be developed. One of the key activities of the design process is modeling the software to express its design. This involves creating visual or diagrammatic representations of the bigger software solution and its subcomponents, as well as the interactions between them. This can be done using simple flowcharts or more standardized methods like UML. A software system can be construed in terms of structural elements. Structured design conceptualizes a software problem into well-organized, smaller solution elements called modules and submodules. Structured design stresses organization in order to achieve a solution. A well-structured design should contain modules that are cohesive and loosely coupled. Cohesion means that all functionality-related elements are grouped together, and coupling is the communication between different modules. For a system to be loosely coupled, the modules should be weakly associated so changes in one component have minimal effect on another. And loose coupling is an architectural principle often used in service-oriented architectures and microservices-based architectural patterns, which will be discussed later in the module. This diagram shows a simplified example billing system. Modules are arranged in a hierarchy and communicate with each other. The rectangles represent the modules and submodules, and you can see that billing is the main module and the other rectangles are submodules to the main billing module. In this example, the submodules are insurance verification, submit claim, and output total. The arrows represent the flow of the data in the system. Behavioral models describe what a system does without explaining how it does it. The overall behavior of a system can be communicated through behavior models. There are a number of different UML diagrams that can be used to communicate the behavior of a system. We will discuss two such diagrams, a state transition diagram and an interaction diagram. When developing a complex software system with interconnected modules, it can be difficult to remember the relationships, behaviors, and hierarchies among different elements. UML, which stands for Unified Modeling Language, is a way to visually represent the architecture, design, and implementation of complex software systems. UML is a standardized modeling language that can be used throughout development processes. UML diagrams can be divided into two classes, either structural or behavioral. UML is programming language agnostic, so software developers can readily interpret and apply it to their work, no matter which language they are developing in. There are several advantages of using UML to communicate architecture, behavior, and structure with development teams. The biggest advantage of UML diagrams is that they allow you to plan out features before any coding takes place, which saves time and money. Secondly, the diagrams can be used to bring new team members or developers switching teams to get up to speed quickly. Also, the diagrams can be used to facilitate communication between technical and non-technical audiences more easily. And finally, having a visual representation of the system allows developers to navigate the source code because they can see the relationships among modules. So, there are many types of UML diagrams, but generally, UML diagrams can be classified as either behavioral or structural. We will discuss behavioral models next, and then object-oriented design. The behavior of a system can be explained and represented with the help of a UML diagram called a state transition diagram. The state transition diagram is a collection of states and events that describes the different states that a system has and the events which cause a change of state in the system. The diagram shown is an example of a state transition diagram that models a patient going to see a doctor at a clinic. The different states include waiting, testing, and with the doctor. The arrows represent possible transitions from one state to another and names the event that triggers the transition. An interaction diagram is used to model the dynamic nature of a software system. They help visualize objects and their relationships. A sequence diagram, which is the type of interaction diagram shown here, displays the communication between objects with respect to time. This example shows a patient making an appointment in an online portal, and this is another example of a behavioral UML diagram. In this video, you learned that structured design breaks down a software problem into well-organized, smaller solution elements. Behavioral models describe the behavior of the system without explaining how the system implements the behavior. Developing UML diagrams saves time and money by helping developers quickly get up to speed on a project, plan features in advance of coding, and help developers navigate resource code easily. A state transition diagram is a behavioral model containing a collection of states and events that describe the different states of a system and the events which cause a change of state. And finally, an interaction diagram describes how interacting objects communicate.